press the bell icon on the YouTube app and never miss another update.
Okay, hello students. See, in the previous class I had shown you the first main in the exercise 2.2. Today we shall solve the second main of that same exercise, that is 2.2. Now on this board I have written 2 points here. First one is the required polynomial is, see, to find out, to get the required polynomial. So the formula which we have to apply is k into x square minus sum of the zeros into x plus product of the zeros. See, in the previous class I had shown you, if you want to get a polynomial, what you have to do is x square minus sum of the zeros into x plus product of the 0. So this formula I had given you when I showed you the example problem in your textbook. Now today let us work with this knowledge, the exercise 2.2 second main. So here the sum and the product is given, sum and the product is given. Here sum of the 0 is 1 by 4 and the product is minus 1. So you need to apply the formula, that is it, and you will obtain the required polynomial. And the second point which I have given is cubic polynomial, which I am going to tell in the end of this class. Now first let us see 1 by 4 and minus 1. Now the required polynomial p of x is equal to, see, you want to find out the required polynomial means we will write the formula first, k into x square minus sum of zeros into x plus product of 0. Close the bracket. Now here k into x square minus sum of the 0 is 1 by 4 of x plus product of the 0 is 1. I hope you understood. X square minus 1 by 4 is the sum of the zeros into x plus product of the 0. Product of the 0 they have given it as minus 1. Now we will try to solve this. Here 4 is the LCM. Now this one will become 4x square minus x, and here minus, here 1 4s are 4. Now here let k is equal to, we shall take it as 4 now. So this 4 into 4x square minus x minus 4 divided by 4. This 4 gets cancelled. So here if k is equal to 4, if you take, this will become 4x square minus x minus 4. One such polynomial, that is the required polynomial, when the sum is 1 by 4, the sum of the 0 is 1 by 4 and the product is minus 1. So this is the first question. So the required polynomial is 4x square minus x minus 4. So when k if you put 4, then 4 gets cancelled. One such required polynomial is 4x square minus x minus 4. If you take 4, k is equal to 4, then you will get this answer, 4x square minus x minus 4. Now the second one I have given it here. So again you write the formula. The required polynomial is, so I will write in the short form, x square minus, so if you take alpha and beta as the sum, you can write like this also, plus alpha beta. Now here, now what is x square here? X square minus, what is alpha plus beta? alpha plus beta is root 2x plus product of the 0 is 1 by 3. Now, see here LCM, I will take it as 3 is the LCM. Now, this one will become 3x square minus, here 1 is the denominator. So, 3 root 2x plus, here 3 is the, so 3 ones are means 1. Now, put k is equal to 3 so that this will get cancelled. So, k is equal to 3 if you put, this one will become 3 gets cancelled. So, 3 into 3x square minus 3 root 2x plus 1 divided by 3 gets cancelled. Therefore, required polynomial is 3x square minus 3 root 2x plus 1. So, this is the required polynomial. This is how you have to do this second main. So, we shall move on to the third one and fourth one. Third and fourth one. Now, third one, 0 comma root 5, and fourth one, 1 comma 1. See, the sum is given, the sum of the zeros is 0 here and the product is root 5. So, let us do again. So, the required polynomial p of x is equal to x square minus alpha plus beta, that is the sum of the 0 alpha beta. So, here now we shall apply the numbers here now p of x. So, here k is there. So, you can take it as p of x, that is k, you can put the value there. So, here x square minus alpha plus beta is 0. So, 0 into x plus alpha beta is root 5. Now, here k, if you put k is equal to 1. So, here we need not worry because there is no LCM. So, put k is equal to 1. So, here, so the required polynomial is x square minus 0 into x is 0. So, only constant. So, x square plus root 5 is the answer. So, if you go on for this fourth one now, fourth one, p of x is equal to k into x square minus sum of the zeros into x plus product of the 0. Now, alpha plus beta is also 1, alpha beta is also 1. So, 1 into x, so I will write only x plus 1. So, you need not worry about this k, let k is equal to 1. So, the given or the required one such polynomial will be p of x is equal to x square minus x plus 1. So, this is the answer for fourth one. Okay, I hope you understood. Now, we shall move on to fifth and sixth sum. Fifth sum is minus 1 by 4 plus 1 by 4. Sixth one, 4 comma 1. Now minus 1 by 4 and 1 by 4. Now again put the formula. The required polynomial will be equal to k x square minus alpha plus beta into x plus alpha beta. Here x square minus alpha plus beta. So here minus sign is there. Again you have minus 1 by 4. So can I write plus 1 by 4x? So minus and minus. So minus into minus it will become plus. Then plus 1 by 4. Now here what is the LCM? 4 is the LCM. Now this one will become 4x square plus here x plus 1. Now let us put k is equal to 4. Now when k is equal to 4, this will become 4 get cancelled. Therefore, the required polynomial is 4x square plus x plus 1. So, the required polynomial is 4x square plus x plus 1. Now, let us move on to the sixth one now. So, here if you remember this formula, then you can solve the problem easily. So, one such required polynomial is 4x square plus x plus 1. Now, the last one, p of x is equal to x square minus alpha plus beta into x plus alpha beta. Now, x square, sum of the 0 is 4x plus and here 1. So, here if you put k is equal to 1, let us put k is equal to 1. So, one such required polynomial will be x square minus 4x plus 1. So, if you take the value k as 1, then one such polynomial will be x square minus 4x plus 1. I hope you understood this exercise 2.2. Now, I had written this cubic polynomial. See, I will just see, here I have written about the cubic polynomial. Actually, it is the question in exercise 2.2, they have not given any such questions related to cubic polynomial, but they have given one example in your textbook, that is example 5. So, example 5 actually they have given not from the examination point of view, but for CBSE they have given this same question in the previous board exam. So, I thought I will do it this sum. Now, cubic polynomial. So, I had given you in the first class, in the beginning of this chapter when I introduced all the terms, I had given you the what is cubic polynomial and the general term. Once again you try to recall. So, cubic polynomial is, the general form is ax cube plus bx square plus cx plus d, and a is not equal to 0. If a should not be equal to 0, then only it will become cubic polynomial. See, if a becomes 0, then it won't be cubic polynomial. You should keep this in mind. Suppose if alpha, beta and gamma are the zeros of the polynomial, suppose alpha, beta and gamma, you know, at the most the cubic polynomial can have 3 zeros. Yes, I told you in the previous class. Now, let us take it as alpha, beta and gamma. So, all this time like in the quadratic polynomial you used to take alpha and beta. Now, one more 0 like this is called as gamma. So, alpha plus beta plus gamma is equal to minus b by a. So, minus b by a means here, see observe carefully, minus b is the coefficient of x square. Minus b is the coefficient of x square divided by, of course this is coefficient of x cube. A is the coefficient of x cube. Same way here, 2 zeros at a time. You should take 2 zeros at a time. I hope I am clear. 2 zeros at a time means here alpha beta, beta gamma, gamma alpha. Yes, alpha beta, beta gamma and gamma alpha is equal to C by A. What is C now? C is the, see here, coefficient of x divided by coefficient of x cube. So, you should note this carefully now. C is the coefficient of x and A is the coefficient of x cube. Now, the last one, alpha, beta, gamma means the product of the zeros. The product of the zeros. Here we took 2 at a time, but in this case we have taken all the 3, that is the product of the 0. So, the product of the 0 is nothing but minus d by a. Minus d by a means here d is what? Constant. Now, d is minus constant term divided by coefficient of x cube. Coefficient of x cube. I hope it is clear now. So, if you remember this, you can solve any problem or to find out the relationship between the numerical coefficient and the zeros if they ask, you can find out using this formula. That is only one example they have given in your textbook. I will try to solve it. Example 5. See, I will read the question. Verify 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial. See, you have to verify. See, there are again 2 parts in this question. One is you have to verify first whether 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial. Which is that polynomial? They have given this polynomial. P of x is equal to 3x cube minus 5x square minus 11x minus 3. 3x cube minus 5x square minus 11x minus 3. And then, so this next part of the problem is verify the relationship between the zeros and the coefficient. Again you have to apply this. So first, how will you find out whether it is a zero of the polynomial? So already you know, so if it is a zero of the polynomial, so they are asking you have to verify whether 3 minus 1 and minus 1 by 3 are the zeros of the polynomial. So if it is 0, then when you substitute that 0 in this variable, you will get the value 0. Yes, so let us do the one sum. See here. Now in this case, so I have to find out whether 3 minus 1 and minus 1 by 3 are the zeros of the polynomial. Okay, now, so let us find out the value of P of 3. Now find the value of P of 3 now. So what you will do? Instead of x you will put 3 minus 5 into 3 square minus 11 into 3 minus 3. See, 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. Now, here 3 into 3 3s are 9 and 3s are 27 and 27 into 3 you have to do. 27 into 3. So, 27 into 3 you will get 81 minus 3 3s are 9, 9 5s are 45 minus 11 3s are 33 minus 3. Now, find out the answer. 81 minus, see here minus and minus is there. So, here 5 plus 3, 8, 4 plus 3, 7 minus 3. So, 81 minus 78 minus 3. So, here 81 minus 81. See, this will become 0. Now, so hence we can say that 3 is the 0 of the polynomial. Then just see what will happen to minus 1. So, if the value is 0, then we can say that that is the 0 of the polynomial. So, the value of P of 3 we got it as 0. So, we can come to the conclusion, yes, 3 is the 0 of the polynomial. Okay, now let us check whether minus 1 is the 0 of the polynomial. Again, same procedure, 3 into minus 1 whole cube minus 5 into minus 1 whole square minus 11 into minus 1 minus 3. Now, here we should be careful with minus sign. So, since it is power of odd number, you all know it will be minus only. So, minus 1. So, this will be minus 3. Now, this is 1 into 1, 1 again, since it is a even number. So, 1. So, 1 minus 5. I hope it is clear. 1 into minus 5, minus 5, minus into minus, plus 11 and minus 3. Now, just see here. Minus 5, minus 3, minus 5 and minus 3. So, definitely it will be minus 11 plus 11 which is equal to 0. Now, again we showed that minus 1 is also the 0 of the polynomial. And the last we have to check whether minus 1 by 3 is the 0 of the polynomial. So, I will do it here 1 by 3. So, here 3 into minus 1 by 3 whole cube minus 5 into minus 1 by 3 square minus 11 into 1 by 3 minus 3. Just check. 3 into minus 1 by 3 whole cube minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 1. Now, here see, to simplify the calculation, see here 3 gets cancelled. So, what remains? What remains now? Minus 1 by 9. I hope you understood. 1 3 gets cancelled and other 3 will remain 2. So, 3 3s are 9 and since it is a odd, so minus. Then here this will become 1 by 9 plus 1 by 9 plus 1 by 9 into this will become minus 5 by 9. Then here minus into minus plus 11 by 3 minus 3. Now, here what is LCM? 9 is LCM. So, here minus 1 minus 5, then plus here 3 3s are 9, 3 11s are 33 minus here 1 9. I hope you understood. So, yeah, 9 is the LCM. This is minus 1 minus 5 plus 3 3s are 9, 3 11 3s are 33 minus again 9 okay 9 3s are 27, sorry, 27. Now, just see minus 27 minus 5 minus 1. So, definitely it will become minus 33 plus 33 by 9. So, this minus 33 plus 93, it will become 0. So, the value of this also became 0. Now, what is the next step now? So, what you have to do is, next step, what is the question they have given? You have to verify the relationship. So, how to verify the relationship? Now, yes, you have to write the conclusion. Therefore, 3 minus 1 and minus 1 by 3 are the zeros of the given polynomial. So, you completed one part of the problem. Now, what is the next step now? Next, what you have to do is, you have to find out, I hope you understood this first part of the problem, that is you are verifying whether these three are the zeros of the polynomial. Okay, now let us see, let us find out the relationship between the zeros. You have to verify the relationship between the zeros of the polynomial. So, for that we have to use this. So, now which are the zeros of the polynomial? Now, zeros of the polynomial are 3 minus 1 and 1 by 3. Now, we have proved that these are the zeros of the polynomial. So, let us take alpha as 3, beta as minus 1 and gamma as 1 by 3. And of course, better to write A. What is A? A is equal to 3. So, if you write this, you won't get confused while doing the sum. So, B, what is B? B is minus 5. Just compare with the general form here, minus 5. Then what is C? C is minus 11. And what is D? D is minus 3. So, this is minus 3. Now, once you write this, you can proceed with this formula now. Now, alpha plus beta plus gamma. So, what is alpha plus beta plus gamma? So, 3 plus minus 1 plus 1 by 3. I hope you understood this. So, here what is the LCM? 3 is the LCM. Then 9, here minus 3 plus 1. So, 9 minus 3 is 6, 6 plus 1 is 7 by 3, 7 by 3. 3 minus 1, 3 is the LCM, 3 3 is a 9 minus 1 and plus 1, okay, 7 by 3. Now, find out alpha plus beta plus gamma is minus b by a. So, what is minus b? Minus b is where we went wrong. Sorry, here actually it is minus 1 by 3. So, this is gamma is minus 1 by 3 and this also minus 1 by 3. So, here minus 1 by 3. So, 6 minus 1 is 5 by 3. 5 by 3. So, minus of minus 5. So, minus of minus 5 is 5 by 3. See here, I hope you understood, sorry for that. 3 see here alpha is 3, beta is minus 1 and gamma is minus 1 by 3. Now here alpha plus beta plus gamma is 3 minus 1 minus 1 by 3, means here LCM is 3 and 9 minus 3 minus 1 is equal to 9 minus 3 is 6, 6 minus 1 is 5 by 3. Now minus b by a is nothing but minus of minus b is what? Minus 5. So minus 5 by 3. So 5 by 3. Hence these two are equal. Next we shall see this alpha beta, beta gamma and plus beta gamma plus gamma alpha. So let us find out alpha beta. So alpha is 3, alpha is 3 into minus 1 plus beta minus 1 into minus 1 by 3 gamma plus gamma is minus 1 by 3 into beta alpha is 3. Now here minus 3 and here this one will become minus into minus plus 1 by 3 and here 3 gets cancelled, minus 1. Now find out LCM. 3 is the LCM here. Here 1 you have to take. 1 3s are 3 3s are 9, minus 9 plus 1, then minus 3, minus 9 plus 1. So minus 9 plus 1, minus 8. Minus 8 means this is minus 11 by 3. Now find out, see here alpha beta plus beta gamma plus gamma alpha is equal to C by A. So what is C? C is minus 11. See, C by A. C by A is minus 11 by A is 3. See here, verified. See alpha beta plus beta gamma plus gamma alpha is also equal to minus 11 by 3. Same way C by A is also minus 11 by 3. And the last one we have alpha beta gamma. Alpha beta gamma is equal to alpha is 3 into minus 1 into minus 1 by 3. So 3 gets cancelled. This one will become minus 1 into minus 1 plus 1. So alpha beta gamma is equal to plus 1. Now see this formula minus d by a. So minus d by a. Minus d by a is minus of, now d is what? Minus 3. So minus 3 divided by a is also 3. See here a is 3. So minus d, minus of minus 3 by 3 means here you will get minus into minus plus 3 gets cancelled, you will get answer. So definitely alpha beta gamma is equal to minus d by a. So hence we proved our this is verification. So we have verified that the 3 zeros here 3 minus 1 and minus 1 by 3 are the zeros of the polynomial first, and in the next part of the problem what we did, we just verified whether the relationship between the zeros and the coefficient. I hope you understood the problem. So this is the example 5 from your textbook.